All right, scholars. The cool thing is here, we're now going to do probability using area, and that's actually the biggest one for us to use. And I want you to, again, imagine like this rectangle is like a dartboard, and I'm trying to decide what's the chance I would, if I threw a dart or select a point randomly, where it would land in here. And so with that, I want you to understand that we're always going to be landing inside the rectangle. So the first thing we have to have every single time is the area of the rectangle. And I know area is base times height. So our base is 50, our height is 28. What do we get here? 1,400 square feet. So I'm going to use that because that is the total sample space. Everything's included in that 1,400 square feet. So now the first thing I'm going to ask, and I like this because they're going to say, please put this in your calculator, because now when we start doing area and stuff, we're going to start getting pi and maybe radicals in there, and it's a lot easier to understand it if we actually do a decimal. So make sure you look at the directions carefully. So the probability of a circle means you have to find the area of the circle first. So I go pi r squared. Well, with pi, my radius is here. If the diameter is 18, the radius is going to be 9. Excuse me here. Oh, bless me. All right, sorry, I blessed myself there. Weird, I know. So then we get 9 and we square it, and we get 81 pi. So I know it's 81 pi over the total sample space, 1,400 square feet. So when I punch that into my calculator, and remember, use your pi key, not 3.14, you're going to get approximately 0.18. So a little under 20% of this is going to be used. Now, what's the probability of hitting this big trapezoid right here? Okay, well, in order to do that, you still have to find the area of the trapezoid. So area of the trapezoid, let's do the hard part first, okay? The sum of the bases times the height over 2. Sum of the bases, 34 plus 16. Our height is 18. All over 2. 34 plus 16 is 50. 50 plus times 18 divided by 2 is 450. So it'd been 900 over 2, which is 450. All right, so I know that's the case, but I want the probability, if I threw a dart, bam, that I'd hit right there. So the probability of the trapezoid, so I'm just going to call probability of hitting the trapezoid, is going to be 450 over 1,400. So when I reduce that, that becomes 9 over 28. So 50 can basically come out of both of those, right? Well, what does that give me as an approximate decimal? That's 0.32. And that makes sense. The trapezoid's bigger than the circle. It should be. We should get more. Then the next one is, what's the probability if I hit one of the two squares? Now that's like if I hit one square or the other is the other way of saying that. But we have to remember you get either square. So find the area of the square, and they told you those are squares, even though there's no right angles there. Remember, you have to find the area of the square. Well, the fastest way to find the area of the square is side squared. It's still base times height, but we're just saying side times side instead. And that's going to be 10 squared. Well, that's 100. And that'd be square feet also. But how many squares are there? There's 2. So I have 100 square feet here, and I have 100 square feet here. What do they add together to be? A total of 200 square feet. So the probability of one of the two squares, so I'm going to go either square, of hitting either square, is going to be 200 over 1,400. That's 1/7, or approximately 0.14. Now these are the probabilities we're working with. We're doing the areas. Your examples are going to be very similar. Now if you're in honors class, know that sometimes you're going to have to put your own numbers in to figure out probability. If you are in my regulars class, just remember on the worksheet it will be very similar to our notes. So make sure you do those well and that you study carefully. All right guys, have a great day.